Implementing cache with the least recent used eviction. Cache has a fixed size. Both inserting and retrieving from cache should be in constant time. When cache is full, the least recently used item must be removed in order to insert new item. So these are the conditions. First condition is that cache should have a fixed size, which means it should not increase that particular size. Second is that the operation here, inserting and retrieving, both should be in a constant time. Third is when cache is full, you need to if the cache is full and you want to add a new item, you can do only by removing one item from the cache, because the cache has a fixed size. So you need to choose the least recently used item. These are the three conditions for the cache. So in order to create such a cache, we need to have some data structure. First data structure is cache map. It's just like a Java hash map. Okay, in that data structure, there will be a key and a value. You can insert an item with the key value in a constant time, and you can retrieve in a constant time. So constant time for inserting and retrieving. Removing the least recently used item would take linear time. So in hash map, you cannot retrieve an item based on its value. For example, you are keeping one of the value as a time it last used. If you want to find out the least recently used item, you need to go through each item. That would take linear time. So when the cache is full, we need to do the linear time to remove that one. So that will violate the condition. We need a constant time for inserting an item. So that's the problem with the cache map. When you want to remove an item from the cache, it will take a linear time. To solve that problem, we will use another data structure. It is basically a double linked list, which would be used for keeping the items in the order of usage. Most recently used item at the head of the list, and least recently used item at the tail of the list. So basically what we are doing is that one, we keep a cache map. Using that one, you can you can do inserting and retrieving in a constant time. But the drawback of cache map is you can't keep track of recently used item, age of the item usage. You can't keep track of with the cache map. For that, we using another a list we are using, in which we will keep items based on its usage. Most recent used item at the head, and least used item in the tail. So whenever you are adding a new item, it will go to head, or if you are retrieving a new item, that will be taken from the list and pushed in front of the head, so that it will become the recently used item. So if the cache is full and you want to remove one item, what you do is that you will pick the item at the tail and remove it. New item will go to head. That's how. Now we know that one cache list is a double linked list. Obviously you need a node to store a linked list. So this is a node, cache node, which contains cache key, cache value. See, it's a double linked list, so you need a two pointer. One is a previous node and another is the next node. The reason why we keep the cache key in the cache node is at the time of removing, we will pick the item from the tail of the cache list. So we want to know the key of that particular cache item, so that you can remove the item from cache map also. Now let us look in the code. So here you can see defining an object for cache URU, LRU, least recently used. So the size of the cache is 3. So you can add a maximum 3 items at a time. So let us look into adding first item. First item key 1 and value 1 we are adding into cache. So you can see here a cache contains key 1. Then we are adding second key and its value. Now you can see here cache contains value key 1 and key 2. Left side is tail and right side is a head. So K2 is the most recent used and K1 is least recent used. Now I am adding third item key 3. Now you can see it is going to head, and this is the most recently used item. This is the second most recently used item. This is the least recently used item. Now I am adding key 1, which means it updating the key 1 because it's already there. So now you can see that one key 1 was the least recently used item. It will go to head part, and the remaining values K2 it is here, K3 it is going here. So yeah, whenever you are accessing or updating, the item will go to head part of the list. That's the most recently used item. So now you can see here key 2 is accessing, retrieving the key 2. Now key 2 was the least recently item. Since it is accessed here, it will go to a head part. Now K2 is the most recently item and K3 is the least recently item. Now we are adding new item K4, and we know that already cache contains 3 value. It's a maximum value is 3. So if you are adding new item, you need to remove one. So here tail part is this one. It's a least recently used item. It will be removed. It will be evicted. Now K1, K2, K1, K2, and new item is added into the head part K4. This is the most recent used item. K1 is the least recent used item. Now here some test is written some test code to make sure whether it's working or not. So here retrieving the K1, and the value should be value 1 new because that is the latest value we added. Second test is key 2, and the value of the you can see here key 2 is still in the cache. So the value of the key 2 is value 2. Then we are checking key 3. You can see here key 3 is not there in the cache, so it will return null. So that's the test here is happening. Fourth is a K4, key 4. We know that one K4 is in cache. Now yeah, print is just checking whether success or not. If it is success, it will return okay, otherwise it will return failed. I will run this code just for testing purpose. It is showing all the 4 tests are okay. It's a success. Now let us first look at the cache LRU class. Before that, we need to look at the cache node. We already discussed we have a cache list to keep track of the usage time when it is used. Since it's a double linked list, we need a node to store in the list. That's a cache node which contains cache key, cache value. Since it's a double linked list, we need a previous node and next node. Now this is the cache LRU. So in the cache LRU, you need a cache map so that you can insert and retrieve at a constant time. And at the time of inserting, we may need to remove least recently used item. For that purpose, we keep a double linked list. It is called cache list here, and cache has a fixed size, so we need to keep that value also here. And here you can see constructor, it accepts size, and we will look into the details later. And is a put. When you are putting data to cache, you need a key and value. And another operation in the cache is get. For get, you need to pass the cache key. It will return the value. Let us look at the double linked list. So we know that one double linked list should contain head and tail. Cache node add. When you adding a value to this double linked list, we need a key and a value. And the remove tail node. We know that one least recently used item will be in tail, so we want to remove that one. So it contains a method remove tail node. Next method is a move to head. Whenever you are accessing a value or updating a value, you need that value is that key is most recently used item. So you need to move that node from the list to head. That node may be anywhere in the list. So you need to pick that node and move to head so that it would be most recently used item. And another method is a detach. You may want to detach the node from the list. Maybe you want to remove a node from the cache list, so you can do the detach, or you want to take out one node from the list and move to head. That also time also you can use the detach. Okay, yeah. Now we look at the main cache node. We look at any cache LRU. Now here we can look at constructor for the cache LRU. So at the time of creating this cache, you need to tell the maximum size and initialize the hash map. We are using Java hash map, and specify the size for the hash map. So here we initialize the cache map and cache list. That's what we are doing in the constructor. Now let us look to cache get. It's retrieving the cache item. Basically, you need to provide a key to retrieve an item. So first, retrieve the item from the cache map. It will take only a constant time to retrieve that data, and we got that node. If the node is empty, means you are trying to retrieve a key which is not in the cache, then you will get null. Then just return null because there is no value for that. Otherwise, you accessed that value. So move the accessed item to head of the list to make it as the most recently used item. So we will move that node just now you access to head of the list, so that it will mark as the most recently used item. Here we are returning that cache value. That's all. It's a get. Now put. Let us look at the put. Basically inserting to cache. First, you need to check the key is already in the cache map. The key is already in the cache. Update the value and move the item to head of the list. So basically, a cache item is already in the cache. So just update the value, and then basically you need to mark that node as the most recently used item. So move that item to head part. So here we are retrieving that cache item from the cache map. Then we will update the value, new value. Since it is accessed now or update now, we need to make it as a most recent used item. So move to head that, so that head part is the most recent used item. It will go to head section of the list. This is what we will do when if you are inserting a cache item, the key is already there in the cache. Now, if the cache is full, remove the least recently used item, which is in the tail of the list. So basically, what you need to do is that we kept the list to keep track of the usage time. In the heads, the side most recently used item would be in the head of the list, and least recently used item in the tail of the list. So we want to remove the least recently used item. So we are removing from the tail node. Remove tail node. It will remove the tail node. Basically, we are removing from the cache list, but the item is still in the cache map. So at the time of removing, we are getting that node which is removed. Then we are removing from the cache map also, because we have two data structure keeping track of the node. So we need to remove from both sides. That we need to remove the node when cache is full and you are trying to insert new item. Now here you can see that adding the new cache item to the cache list. At the time of adding, it will return that node, added node it will return. That will go to cache map, because we have a two data structure to keep track, to keep the node. Yeah, that's all in the this is the cache two methods. One is a put, and put for inserting, and get for retrieving. Now let us look the double linked list. First, let us look the remove tail node. Yeah, we need to remove the tail node. First, I am storing the tail to tail node. Because this detach will change the tail this tail variable would be changed by detach. So first we need to keep store the tail here, then do the detach. Basically the detach is to take out the item from a list. We know that when each item contains previous and next node. Here you can see that one. A previous node and next node pointer are there. So if you're removing an item from the list, need to make sure that one the item before that and item after that connected by modifying it these nodes of those two items, the neighboring items, so that you can remove the one node. So that this detach will do all the stuff. It will look neighboring nodes and will connect. Yeah, remove tile node, we need to return the removed item also. It is removing that one, returning that. That's a remove tail node. Here move to head. If you want to move one node in the list to head part, first you need to detach that one, because it is a 1.1, it's one the node is in the list, somewhere in the list, so you can't remove directly that one. First you need to detach that one, so that neighboring items will be connected to each other. That's a detachment we're doing here. Then we need to make it as a head. That node, we need to make that node as head. So first take the head pointer and make as a previous of the new node, then make that new node as a head. That's it, because we have already one head and we want to make sure that this node which we want to make as a head node. That's what is happening here. Now detach. So basically, if you want to detach one item from the list, if there is no next node to that node, that means that node is in the head of the list. That's why there is no next item. So you want to detach that one, so you need to make sure that one head get the new pointer, because you are removing the item at the head. So you can use node dot prev node. The previous node become a head node. Otherwise, it is the item we want to detach is not at the head. Then we need to do another this calculation. The similar way, the node may be at the tail of the list, so you need to change the tail pointer. Otherwise, another calculation here, because the item is not in the tail. And then since this node is detached from the list, you can make these 2 pointers as a null. Next node and previous node is null. That's it. That's a detach. We looked at the move to head, removing tail node, and add everything we looked at. I think that's all. So this is how we need to implement. I explain all the classes, right? Okay. Yeah. Basically, we need two maps. One is a cache, and we need two data structure to implement a cache with the least recently used eviction. One is a cache map, another cache list. Okay, using the cache map, you can insert and retrieve at constant time, but it won't support removing the item based on its usage time. For that, we need a list, a double linked list, where we will keep the items based on its usage time. Most recently used item at the head of the list, and least recently used item at the tail of the list. That's all. Thanks for watching.